The apparatus I have here is known as a RippleTank. It is a highly effective way of using water waves to examine characteristics and properties of all waves. This RippleTank has a light source that shines down on the water, and the water is in a glass bottom trough. So as the light shines down through the water and the light refracts over the waves, it creates series of shadows and bright lines below. This one is made as a demonstration RippleTank, so when the light shines down, instead of looking at the table below the RippleTank, it hits a mirror, and the mirror reflects it out onto this translucent screen here so that you can view it from outside. You don't have to be right on top to look at it. We have a couple of wave generators. This one will generate plane waves. It's like dipping a ruler in the water repeatedly. It'll generate plane waves, while as this one, it will just go up and down like dipping your finger in the water, and it will generate circular waves. These two wave generators have adjustable frequencies, so I can adjust the frequency of each one to produce the better viewing waves. This setup also comes with a strobe filter, so that by placing the strobe filter underneath the light source, I can adjust the frequency of the strobe and create pretty much stop action movement, so we can look at the wave pattern without it continually moving. This is a really nice setup, and I'm going to use it to look at properties of diffraction, reflection, interference, and refraction of water waves. Here you see a plane wave. The wave is propagating from the top of your screen to the bottom of your screen as a plane wave front. I can adjust the amplitude and turn this wave on and off so that you have a better view of, say, individual wave fronts. One of the first wave properties we study is known as reflection. Reflection is when a wave turns back after it reaches the boundary of the medium through which it's traveling. We really don't like to use the phrase bounce off when we describe reflection. So instead of saying the wave is bouncing off, we say it turns back. I'm going to put a straight barrier in my tank. I can get it to stand up, and we're going to look at the pattern of the reflected pulse. So you can notice how when the wave reflects off compared to the way it went in and hit. If I put the strobe effect in this and cause a more or less a still motion, we get an interesting result if the obstacle is at a perfectly 45-degree angle to the wave. The stop action motion will make it look a lot like the checkerboard pattern. Here is reflection of a plane wave off of an angled straight barrier. Reflection of the plane wave off of a circular barrier. So here I have a barrier that we will describe as being convex. The wave is hitting it from the convex side. Notice the shape of the reflected pulses. So as the wave goes in and hits that convex shape, it reflects back as a circular wave. If I turn that shape around, we'll have a concave shape. When the wave goes into the concave shape, it reflects inward, and if I let it go continuously, you can actually see a place known as the focal point in here. Here is reflection of a plane wave off of a concave barrier. Here is reflection of a plane wave off of a convex barrier. Another property that's easy to show with the plane waves is diffraction. Diffraction is the spreading of a wave around a barrier or through an opening. I'm going to place a barrier in the water tank, and I will turn on the plane wave, and what you'll notice as the plane wave goes around that barrier, it tends to reconnect on the other side. So as the wave comes in and gets to the barrier, it spreads out after it goes around that barrier. So diffraction is also not only the spreading of a wave around a barrier, but it's the spreading of a wave through an opening. So I'm going to place a second obstacle, leaving a little gap between the two of them, and so we'll have an opening for the wave to come through. And you'll notice after the wave goes through that opening, it comes out as a circular wave spreading back out. So you see diffraction around the two edges on each side, but also diffraction in the middle through that opening. Here is diffraction of a plane wave around a barrier. Here is diffraction of a plane wave through an opening. Another wave property is refraction. Now refraction is sometimes a little bit difficult to notice with the ripple tank, but I put in another block, a transparent block. This is a triangular shape, and the light will still shine through it, but it makes the water shallower above that shape. The speed of a wave in water depends on the depth of the water. So refraction is defined to be the change of direction of a wave as it passes into a new medium obliquely, which means at an angle, and it changes speed. So if a wave goes into a new medium at an angle and changes speed, it will refract somewhat. You should notice a little bit of refraction as the wave goes over the triangular shape on either side, where it doesn't keep going as a plane wave in that direction, but it changes its direction a little bit. It's not always easy to tell on this unless you really knew what you were looking for. So there we have wave properties illustrated by the plane waves: diffraction, refraction, and reflection. Interference is the fourth wave property, and we only notice interference if you have two or more waves at the same time. So I'm going to have to put the second wave generator in, and we'll look at interference of two waves. Here is refraction of a plane wave. Here we have a circular wave. This little ball is dipping repeatedly up and down in the water. I can turn it off and then turn it on to send out a few individual pulses. So let's look at reflection of a circular wave off of a plane barrier. So in this case, the circular wave will go out, strike the barrier, and notice the reflected wave. After it reflects off of that barrier, it reflects as a circular wave. We can also look at reflection of the wave off of the convex and the concave barriers. So there's the convex barrier, and here will be the concave. Here is reflection of a circular wave off of a convex barrier. Here is reflection of a circular wave off of a concave barrier. Circular waves will also diffract. So I place an obstacle in the tank, and as the circular wave goes past the obstacle, it spreads back out. So we notice diffraction around the obstacle, and it will also diffract through an opening. So if I place the two obstacles in, leaving the gap in between them, when the circular wave goes through there, it diffracts, spreads back out, so you see a circular wave coming out of the gap. Here is diffraction of a circular wave around an obstacle. Here is diffraction of a circular wave through an opening. Circular waves will also refract, although it's sometimes difficult to notice. Here is refraction of a circular wave. Interference is the result of the superposition of two or more waves. Basically, what happens to the medium when two or more waves are in the medium at the same time? So here I have two circular waves. They both have the same frequency, and they are going up and down in the water, and wherever the crest of one wave overlaps the trough of another, we have destructive interference, and when the crest of one wave overlaps the crest of another, or a trough with a trough, we have constructive interference. The interference pattern that you see should be able to display some shadowy lines going in between the two circular waves. That's where we have destructive interference all the time. Those are called nodal lines. Nodal lines. The closer our two sources are together, the more spread out the nodal lines are. If our sources get farther apart, the nodal lines become more plentiful and closer together. So this is the interference of two circular waves with a wide spacing, lots of nodal lines closely spaced versus a narrow spacing of the two waves where the nodal lines are fewer and farther apart. Here's the interference of two circular waves. And so we have a plane wave and a circular wave. And on this one, you'll see nodal lines that travel in between the two, like this. So the plane wave and the circular wave is also an interesting phenomenon, their interference. Here is the interference of one plane and one circular wave.